Look, the jinn what is what telling. We used to sit in the atmosphere, and we used to listen to the exalted assembly out in the universe. We used to listen. But now, there is shooting stars waiting for him. What does it mean, this? We will check this.
As the mesosphere extends upward above the stratosphere, temperatures decrease. The coldest part.
This is in the last episode we spoke about the layers of the atmosphere. Now we will speak only the mesosphere. What is the job of the mesosphere?
Our atmosphere are located in this layer and can reach minus 90 degrees centigrade. The gases include the oxygen molecules continue to become more dense as one descends. As such, temperature increases as one descends, rising above 5 degrees Fahrenheit, minus 15 degrees centigrade, near the bottom of this layer. The gases in the mesosphere are now thick enough to slow down meteors, hurtling into the atmosphere where they burn up. A meteoroid is a solid body in interplanetary space before it reaches the Earth's atmosphere. Meteors are caused by the entry of small pieces of rock, dust, or metal from space into the atmosphere at extremely high speeds. They could travel at this rate very easily in a vacuum of space because there's nothing to stop them. Earth's atmosphere, on the other hand, is full of matter, which creates a great deal of friction on the travelling objects. This friction generates enough heat to 3,000 degrees Fahrenheit or 1,649 degrees Celsius.
You know what I understand? The jinn is coming here to listen to the people in the universe. Here, it cannot go out. But it's hit always billions. There is billions of asteroids, billions each day coming, billions, and like this it's burned in the mesosphere. If we didn't have mesosphere, the billions of stones it hit us. But because we have the mesosphere, all these billions of stones are burned. شهابًا ثاقب يقذفون بشهاب ثاقب. They are burned. The jinn is coming here and is thrown by the mesosphere with the meteorites. There are millions each day, 100 tons of meteorite. It's burned in the mesosphere every day.
To raise the meteoroid's surface to its boiling point. So this meteoroid is vaporized layer by layer. A meteor denotes the fiery streak or shooting star, which appears when a tiny meteoroid strikes the Earth's atmosphere and burns up. Most meteors result from meteoroids no more than a few centimeters. Up to 25 million meteors arrive each day.
25 million meteors each day are burned in the mesosphere.
It is estimated that anywhere between 44 and 100 tons of meteor.
100-ton meteors every day is burned in the mesosphere. The jinn going there, it's hit by Shahab and Saqib.
Big material fall on the Earth each day after it burns up in the mesosphere. Imagine the Earth being pelted with up to 25 million meteors each day without the protection of the mesosphere.
Okay, just to give an idea. Look, if you, jinn and mankind, if you can get out of the atmosphere, you cannot get out. Look, it's written. He will send upon you flame, fire and smoke. Not fire and smoke. Shawaz bin nar wa nuhas. It's not the smoke. Nuhas is a smoke, Master Ara. Nahas is a smoke. It's iron, nickel and copper. I will send fire, iron, nickel and copper. Look what they translate. Fire and smoke. He will send on you fire, and nuhas means nickel and copper. We will see in the asteroid if there is nickel now.
Our dear planet Earth is in the hotbed of cosmic activity this year. Let's recap some recent news. A meteor explodes over Russia. An asteroid barely missed crashing into Earth. And later this year, we will see a comet in the skies that will shine brighter than a full moon. Asteroids, comets, meteors. Ever wonder about the difference among those three celestial bodies? Asteroids are usually made from space debris like rock, although some are comprised of nickel or iron.
You see the asteroids, some of them, they don't have iron. If they don't have iron, they make air blast, they burn in the sky. But if they have nickel and iron, it reaches the Earth. Okay? This is two kinds of meteorites. One there is iron, one there isn't. If there isn't iron, it may explode in the air blast. But if there is iron, it reaches.
The bodies range in size from a boulder to hundreds of miles in diameter. They orbit around the sun. Some asteroids have struck the Earth in the past, but most don't survive passing through our planet's atmosphere. Comets are essentially space equivalent to snowballs.
Okay, you know what comets is? It's ice, water. Snowball, 13 snowball is telling comets. Now you learned comets are watery ice snowballs, and there is meteorites without iron that make air blast, and there is meteorites with iron that hit this
Unlike the asteroids that are mostly found in the inner part of the solar system, comets begin their life outside the solar system.
Okay, I think we are enough of this. Now look what he's speaking. أن ينزل من السماء جبال فيه برد. What? God, He sends down from the sky hail like mountains. No, this is not the translation. He tells Jibal, mountains, there is barad, ice. But the translation is wrong. I will say another translation. Look. Oh, this is correct. Sending down from heaven mountains wherein is hail. Okay, this is the translation. God sends, I send the mountains, there is barad, hail, water. I send mountains, there is hail, water. Yani comet. The comet, dirty snowball. Is the water, did the water of the earth come from heaven also? We will check this.
Our oceans came from space in a torrential shower of meteors.
You see, even the water came from space, from comets. They are dirty snowballs.
But one question remains. What could have caused so many asteroids to swing out of their orbit and come crashing to Earth? The culprit appears to be the biggest planet in the solar system. Jupiter lies just beyond the asteroid belt, and its mass is so great that its gravity disrupts any object it comes near. In the distant past, it pulled thousands of asteroids out of their normal circular orbits into elliptical orbits that cross the path of the Earth. When that happened, collisions were inevitable. The Earth was bombarded. As the asteroids crashed to Earth, they smashed apart. Water inside them.
He's speaking wrong, okay? It's not asteroids, it's comets that bring water. The asteroids, they have nickel and stony substance.
Explosion by explosion, they created the oceans we see today. Scientists used to think it took hundreds of millions of years for the Earth to acquire its water. But recent evidence suggests it arrived remarkably quickly.
Okay, we understood now that even our water in the Earth came from comets. Comets, they have water, okay? Not the iron only, the water also. Now, we will learn something from this guy. We will learn something from this guy.
That many meteorite hunters bring magnets back.
This is, you can benefit from this. If you see a stone in the garden, you know if it's meteorite or no. How you can know? Because 1 pound of meteorite is $200-300. And if you find a stone, maybe it's $1,000. How you can know that this is a meteorite. Okay, if you walk in the garden or something يعني in the forest, thank you, and you find a stone, you can check it. This is 3 tests you can make. You know it's a meteorite. You can bring it home. The first test.
Feel with them. Hopefully you have your magnet suspended from a string.
The first test
is extra sensitive.
Magnet must catch it.
What you're going to do is
strong
hold the
magnet.
string with the magnet coming down until it's still. And then you bring the rock to the magnet, not the magnet to the rock. This is so that if the rock happens to have a small amount of iron in it, the magnet will actually swing over a little bit and deflect, and you're able...
Okay, if the stone attracts the magnet, it passed the first test, because there is iron nickel like this, it's a magnet. If there isn't iron nickel, it will explode outside.
To see it has some iron in it. If you just had a magnet without a string, you'd bring the rock to the magnet and you wouldn't feel anything with your fingers. But the string will let you see that there actually is an iron component to the rock. Now on the flip side, because the rock does show some content of iron, it does not mean it is a meteorite. It's simply if it shows no iron content, then it can't be a meteorite. There are plenty of terrestrial rocks that have a ferrous component to them.
There is other stones also they catch the magnet, but it passed the first test. For example, hematite stone, it catch the magnet also, but it passed the first test. We will see the second test.
Which is why we have the second and third test. On the surface test, we are actually going to be looking...
The surface test, it must have a smooth surface. Smooth, not pointy.
At the surface features of the stone, we are looking at the texture of the surface. We are looking for possible pinheads of iron flecks on the surface, and we are looking for contraction cracks on fresh stones.
Look, this is the second test. It's melted outside. Inside, no, different, because it's passing like fireball. This is the second test. It's melted outside, the crust. But inside, no, it's different.
Not all meteorites look the same.
That one is black, but this one is brown. Why? If it's passed the iron test, and if it's have melted crust, if it's black, it's new. If it's brown, it's rusted. You know, it's old. It became rusty. You understand, Mr. Ara? Yani, for example, this is catch the magnet, and it has crust. Okay, it's metal, but it's not black. It's brown. It's old. It's not new because it's rusted. You know.
And more expensive.
It's old. This one. Not beautiful, maybe, not expensive.
They start out black, but because of the iron, they begin to rust.
You see, it rusted. This one, it become brown.
Turn reddish, and then reddish brown, and finally they turn into a deeper brown. And that's how they will be found. The starting skin of all meteorites is the fusion crust.
You see the fusion crust?
It's the burnt surface that occurred to that stone as it passed through the atmosphere.
This is the second test, huh?
1,000 miles an hour. Now this fusion crust, this skin that burned, often has contraction cracks on it, but you'll only see those on fresh meteorites. Any holes on the surface of a stone pretty much condemns it because meteorite...
Look, this is not the meteorite because it's melted outside, but it had not smooth surface. This is lava.
Meteorites do not have holes. If
They
it looks
don't
like
have
a molten
holes.
rock, nice and melted, it probably is lava.
It's lava. If it has holes, it's not meteorite.
It is not a meteorite.
Okay, if it passed the second test, there is the third test. If it pass, it's a meteorite. Okay, to pass the second test, No sharp edges, smooth features,
To pass the meteorite surface feature test,
no bubbles, no hole.
we need to see surface
Look.
features that are compatible with meteorites, as in no sharp edges, as in a fairly nice, smooth feature over it, but the actual texture of the surface is slightly rough, and it needs to have no vugs or holes like lava rocks. Now's the time to do the window test. Now take your grinder or
This is
your
the last
file
test.
or whatever tool you brought to make a small window,
This is your job,
meaning
Mr.
flat
Kost.
spot, about the size of a thumbnail, which is about 2 or 3 square centimeters, into the rock. And that is going to become a window to see what the rock's matrix is made of.
When you sandpaper it, you see the
cannot see the
window.
matrix.
You open a window, you know this, Mr. Arab.
Through some
You open a window.
in the rock. You have to grind it down to a fairly flat polish of roughly 40 grit or better. Now what you're looking for is iron, flex,
If you still flex like this, this is the third test. It's meteorite.
or shapes of chondrules. If it's an older weathered stone, it may not have
If you see the specs,
You'll be able to recognize
it's iron.
chondrules.
But this new,
They're looking like
if it's
small
brown
points
rusty, okay, it's a
that are
meteorite again,
off-colored
but
into
it's
the
old.
background matrix, and they clearly show a pattern of roundness in the middle of nothing. Note the different types of matrices.
You see, this is iron,
See in a meteorite.
iron. If you see
You're
this,
looking for something that looks like
sometimes you can put water over it, you see much better. You need to put water, you see the specks of iron. This is a meteorite. It passed the 3 tests. Okay, you know now how to find a meteorite.